Hello there. Today we are going to reveal you about a productive mechanical method of removing aquatic weeds. Aquatic weeds has been a greater threat to our aquatic ecosystems and irrigation systems, and removing them also has been even a greater challenge. The severity of those aquatic weeds might extend even to the greater losses of aquatic fauna species, and the diminution of the intended capacities of the reservoirs, or tanks or canals, which could finally result scarcity of foods. And this might finally affect even a whole country's productivity, starting from those small villages. We thought to share these details about the functionality and the advantages of introducing an aquatic weed harvester for Sri Lankan irrigation systems in comparison with the previous methods used, since this might change the way you see it in a positive way derived from general perspectives, comparing it with other government projects. Before introducing the aquatic weed harvester and its capabilities, let's establish a basic knowledge on what are aquatic weeds and what are the impacts. When the aquatic flora species populations become invasive or excessive in extent and reduces the exposed water surface, obstructing the balanced performance of an aquatic ecosystem, these excessive vegetation growths are considered as aquatic weeds. The excessive growth of these aquatic weeds can be agitated by different chemical and biological conditions of the waters. Mainly those weeds assimilate large quantities of nutrients from the water, reducing their availability for plankton algae, also increasing the BOD levels, which would eventually cause the destruction of both aquatic flora and fauna. For the ease of understanding the immenseness of the effect of those aquatic weeds, here we have demonstrated it simply using the three pillars of sustainability respectively, environmentally, economically and socially, where the sustainability is put at risk regionally, and eventually nationally. For environmental effects: increased biological sedimentation rates, evaporation mitigation affecting the microclimatic comfort levels, overall threat to aquatic fauna and flora, diminution of water quality, generates conditions with bad odors, negatively affects to the environmental aesthetics and navigation. For economical effects: direct negative impact to all type of agricultural activities when the intended capacities are decreased. Mostly used manual removing method in Sri Lankan context have put the laborer's health at greater risks with diseases, and there, another amount of public money should be spent to recover the vast spreading diseases. Efficiency becomes very low and results a larger cost. Diminution of freshwater fish production. For social effects: threat to all type of rural agricultural and freshwater fishery livelihoods, with reduced flows of canals and tank capacities. Health issues with increased mosquito habitats. Might generate quarrelsome conditions between different social parties. Those are the examples that shows the immenseness of the effects of aquatic weed as a threat where the sustainability is put at risk finally. Here we have provided a simple classification of aquatic weeds based on various habitats which form their eco-environment and become conducive for their growth, reproduction and dissemination. And there might be other different classifications based on different factors of concerns to stratify. Planktonic algae, filamentous algae, emergent weeds, surface floating weeds, submerged weeds, marginal weeds. Here are some commonly found aquatic flora species in Sri Lankan context that can be a threat when overspread. Since we have discussed the immenseness of the effects of aquatic weeds, there emerges the need of managing the aquatic weeds for a productive performance of social, environmental, and economical pillars. So, in managing there are basically two types of approaches. One is the preventive approach, and the other one is the controlling approach. Here weed controlling means keeping the weeds at a level where their effects do not cause economic, environmental, or social damages. Quarantining is an example for a preventive approach. Like these, the preventive approaches commonly have the community action-based enactments and suitable defined laws and regulations. The success of both these two types of approaches always depends on the type of weed species, its biology, means of dissemination, and amount of effort needed to be applied. There are basically 4 methods of controlling the aquatic weeds: manual methods or cultural methods, chemical methods, biological methods, mechanical methods. Finally, there's also the mixed method where 2 or more methods are used. In cultural methods or manual methods, human workforce is used to remove the weeds manually, but this method accommodates a set of risks regarding laborers' safety and health. In chemical methods, there's always the risk that the herbicides which are used remains in water as residue, especially in areas where there are less control or no control over usages. So, there is an environmental risk. Biological methods. Biological control of aquatic weeds is a broad term where the exploitation of living organisms or their products to diminish or avoid the growth of weeds. The complexity of biological method is very high since we have to delicately concern few factors. A strategic long-term planning. Multiple tactics to deal with diversified conditions. Manipulation of cropping system to interact with the environment. Now let's turn towards the mechanical aquatic weed controlling methods, where any group of weeds are removed with machine power or any other tool. The advantages of mechanical methods starts from immediate results. It's non-selective and hardly create any conditions to have ecological shifts for aquatic flora species. And also, mechanical methods often reduces the immense nutrient loads of eutrophic water bodies, indirectly controls the future weed species populations. There are several methods of mechanical removing, like cutting, chaining, water weed cutters and harvesters, dredging, mowing, netting, barriers, burning, fire heat treatment and checking weed seeds, etc. Now, let's focus towards the aquatic weed harvester. It's true that the capital for an aquatic weed harvester is very high, and if not used with a strategic plan to make use of it efficiently to make the final results productive, this would become a white elephant project undoubtedly. But here's the argumentation about the relative efficiency, the productivity, and the economical advantage, where we could save a large amount of public money, and avoid heath and safety risks. An aquatic weed harvester, with well-trained operators, can easily remove weeds of a fully covered, 2.6 hectares of surface area comprised tank within 6 to 8 days, where the traditional manual method takes up to 25 to 30 days of labor works, with all the health and safety issues, and generates, grossly, a 5 times larger cost than using an aquatic weed harvester. The other advantage of this is that, with the help of an excavator and a dump truck, we can remove the aquatic weeds off-site for compost production sites, parallel to the weed harvesting from the tank. According to our calculations, the continual strategic usage of an aquatic weed harvester can recover that large amount of capital within a year, where we had to use it for the acquiring of the weed harvester at the beginning. And within 5 years, the effect of this weed harvester would generate a huge advantage economically. This is Kopathwa in Beliata, Sri Lanka, a tank where its exposed area is about 2.6 hectares, where the Southern Provincial Irrigation Department of Sri Lanka took their first application of this aquatic weed harvester. The efficiency of the machine do depend on the operator's skills to make the full use of it. The idea of the Southern Provincial Irrigation Department is to finish harvesting and increasing the capacities of hundreds of tanks as much as they can from the hundreds of tanks, reservoirs and canals which are maintained under Southern Provincial Irrigation Department, and moreover, the department hoped to lend the machine even for other areas where it would generate another income to the department and the government. This is the result, after approximately 10 working days, 8 hours per day done by the operator trainees. But we have the advantage of using this aquatic weed harvester, even at the nighttime, introducing the shift working systems for operators. And this is beyond human capabilities. Regarding the workability, with the lighting conditions, if we use the traditional manual methods, using only human workforce. So we guess that we could convince you well enough to change the typical notions through this video, about a project like this, about the effectiveness of the usage of this aquatic weed harvester and the cost effectiveness. So, see you in another episode like this.